All right, let's have fun with this one. We have the point 1 plus I, and we want to raise it to the 8th power, and we want to find its result in a rectangular form. Or I want to give you the challenge to find it in its rectangular form. And we can do that by still using DeMoivre's theorem. And to do that, let's convert this over into our polar form first. So we're in rectangular form, let's convert it to polar form. So we need to find both our r and our theta, our modulus and our argument. So to begin with, we can find r was the square root of a squared plus b squared. 1 squared plus 1 squared equals root 2. So we have r equals root 2. Now we need to find its argument, its theta. And from there I can find its theta, which was the tangent of theta, equals its b over an a. 1 over 1, fairly easy. Or just 1. So which angle produced a tangent of 1? That's the inverse tangent, was pi over 4. So we know that theta equals pi fourths. And since this is in the first quadrant, because if I plotted that out, that's in the first quadrant, I know that the angle I have for tangent is pi over fourths, and I'm not having to look for the tangent in a different quadrant. All right, so now let's write that in its polar form. So I have its point z, which we know is r, which is root 2, times cosine of the argument, which was pi fourths, plus I sine pi fourths. All right, so the first thing I was able to do was raise it or convert it from rectangular form to polar form. Now I can use DeMoivre's theorem to take its power to the 8th power. So I want to go z to the 8th equals this entire thing right here, root 2 times cosine of pi over 4 plus I sine pi over 4, all to the 8th power. I'll break that down a little bit. So remember, we take the power of the modulus to the 8th. So this becomes root 2 to the 8th. And then we add the arguments 8 times. So cosine 8 times pi over 4, adding pi to the fourth to itself 8 times, or use multiplication. And the same thing over here, 8 to the pi over 4. Okay, so that was an application of DeMoivre's theorem. Root 2 to the 8th, root 2 times root 2 times root 2, all the way, 64, 2, 4, 6, 8, 16. Root 2 times root 2, I gotta do some work here. Root 2 times root 2 equals a 2. I'm gonna do that 4 times, 2 to the 4th, 16. 16 times cosine 8 pi times or divided by 4 gives me 2 pi plus I sine of 2 pi. 16 cosine of 2 pi was a 1 times or plus I sine of 2 pi is 0. So that could be 16 plus 0i, or just 16. So that was an application of how we can take a point in rectangular form, use DeMoivre's theorem, but in order to use that, we need to transition it over to polar form, and then from there we're able to use an equation that we were able to derive earlier in this section to solve this particular problem.